Hello. In this video, we're going to just crank out a bunch of problems. And so a key to finding success or for this to be useful is for you to pause the video and try these problems on your own and also give yourself time to think. I'm going to try to do this just in one take. So if I make a mistake, maybe check the comments for a correction. But hopefully I don't make mistakes. But a good reminder that it's always good to check your work in math. So here when you evaluate, when A is 5, just plug in 5 for A and then add these together to get 13. So everywhere you see A, you write 5. Here, everywhere you see P, you write 16. So P over 4 would be 16 over 4, which is just 4. And then here we have 17 plus y squared, and y is 3. So you write the 3. If you want to use parentheses, it might be a good habit. It's probably a good habit to get into doing that just for future problems. This one, it probably won't matter, but if a negative sign, sometimes that parenthesis will help you out. But we square that first, so 7 plus 9, and then simplify that to get 16. Remember to pause the video and work these out. Number 4, substitute in 2 for m. So everywhere you see an m, write a 2. And then you're going to do everything on top before doing anything on bottom. So you can't like divide these first. So multiply and then add. So you get 4 plus 9 over 2, which is 13 over 2. And we're just going to leave that as 13 over 2. If you wanted to do 6.5, you can. But as we get further along in our math careers, the improper fraction is king, right? That's what we like. So we'll leave that there. And then on this number 5, plug in 3 for x. So it's 3 times 3. And then 3 minus 1. So that's 9 over 2. Multiply on top, subtract on bottom. And it's 4.5. So if you wanted to write it as a mixed number, you could. If you wanted to do a decimal, you could. But once again, improper fractions are king as you get further along in your math career. Okay, we're going to translate these. So the difference, this means subtract, of 19 and a number t. So it's 19 minus t. The sum of a number p and the square of a number b. So sum means to add. So we're going to take p and add it to the square of a number b. So that would put the exponent up top there. And then number 8, 2 times the sum of a number x and 4. So 2 times is twice, or times 2. And then the sum of a number x and 4. So 2 times the sum of a number x and 4. This implies that this is all going to be in parentheses. So it's 2 times x plus 4. So we're going to find the sum, which is add first, and then take it times 2. Okay, now we're going to write an equation or an inequality. So the sum, which means add, twice, which means multiply 2, and then is our equal sign. So the sum of twice a number d and 3. So that'd be twice d, and then add 3 is equal to 12. Next one is 6 less than 4 times the number j is 18. So is equal, less is subtract, and then 4 times would be multiply. So we have 4j, and then we want 6 less, so you subtract after that. So 6 less than that, you subtract 6 and get 18. Subtraction is tricky with the order a lot of times, so you might pause and think about that for a little while. Look at it again. The next one, the difference of 10 and a number w is no more than 8. So no more than, let's see, if it's no more than, then it can't be 9, because that would be more than. It could be 7. So this is going to be our less than or equal to, because it could also be 8. 8 is not more than. So the difference of 10 and a number w, so this would be 10 and a number, difference is minus w, and it's no more than 8, so it's no more than 8. And this is fine here. Also, if you wanted to, you could put absolute value bars around this, because that will make sure that the difference is positive, but you don't have to do that necessarily. What the absolute value bar does is it makes it so the order and subtraction doesn't matter. It'll just find a positive difference. Okay, the next one, we want to check whether the given number is a solution of the equation or inequality. So to check, you're going to see if it makes this equation true. So that 12 is part of the number. That's kind of, I have a space there, it looks like. But z minus 4 is equal to 9, and you're going to plug in 12 for z. So 12 minus 4, is that equal to 9? And it is not. It is not. So we say these are not equal, because this is equal to 8. 8 is not equal to 9. So this is not a solution. Here is k minus 8.2 less than 10. We have 18 for k, and then minus 8.2. Is that less than 10? And that's true, because it's going to be 9.8 is less than 10. So this is a solution. That's good stuff there. Okay, and then on 14, it's asking to identify the domain and range of the function. So domain is the x values, or the inputs, and range is the outputs. So this is almost like a definition or memorization question, or almost as close as a memorization question as we get in math. Domain, you just have to remember it's the inputs, range is outputs. So the domain, just list them 0, 2, 4, and 6. In the range, list them 1, 5, 9, and 13. Okay, on 15 and 16, we want to tell whether the pairing is a function. So for it to be a function, the inputs cannot repeat, or the input can only go to one output. So 3 only goes to 7, that's good. 5 to 5, good. 7 to 3, good. 8 to 2. So these don't diverge and go to two different spots. And so this is a function. Let's see what happens here. Here, the shortcut would be looking for the inputs repeating, which it happens. If we wanted to line these up, our inputs would be 2, 4, and 7. And our outputs would be 0, 1, 2, and 3. 2 goes to 0 and 1. So you don't know. If I say I put in 2, what do you get? Maybe 0, maybe 1. There's no way of knowing. And so that is not a function. Remember, it's okay for the y values to be the same, but it's not okay for the x values to be the same and to go to two different y values, or for the inputs to be the same and to go to two different outputs. Okay, remember to pause the video if you need to. 17, we're going to graph this function. So the domain is subtracting 2 each time. So if we want to do like an XY table, 2, 3, 4, 5, and 6, then we just subtract 2, 0, 1, 2, 3, and 4. So take a minute to look at those, make sure you understand where those values come from, and then just plot your points carefully. 2, 0, 3, 1, 4, 2, and hopefully you can start noticing the pattern too, because this is a line. But do not connect the dots. If you connect the dots, it's incorrect, because we're told the domain are only these specific values, not everything in between. Okay, so identify the domain of the function. So the domain is the x value. So this is 1 here, and then 2, 3, 4, and 5. So those are the x values that correspond to the points there. And the y values start at 2. If you need to fill those in, or the outputs would be 2, 3, 4, 5, and 6. Okay, and then we want to identify a rule for the function. So we're going to say y equals, and then look for a pattern. If you need to write a table, you could. These kind of line up as is. So I'm taking x and I'm adding 1 each time to it. If I do x plus 1, I get 2. 2 plus 1, I get 3. 3 plus 1, I get 4. And so that is my function rule. Okay, so once again, that was pretty quick. So if you did not pause the video, you might want to stop, rewatch some of these problems, and give yourself a chance to think about them before moving on to the next one. But reach out if you have any questions.